What would happen if the superball from number 3 was initially moving at 0.25 meters per second to the left? What would the velocity be after the collision? Well, I have lots of information that I can reuse. I know that this superball has a mass of 0.015 kilograms, and it stays that way. And I know that this superball has a mass of 0.03 kilograms, and it stays that way. And I know that this ball is traveling at 0.225 meters per second in the beginning, but then they changed it. They changed the value that this superball is traveling to a velocity that is also 0.225 meters per second. So my net momentum equals 0.015 times the quantity 0.225 plus 0.030 times the quantity, and now this is where it gets tricky because it's negative 0.225. And so you get the beginning of this is going to appear exactly as the problem before it, but when you do this math, you get negative 0.00675. And that means that the net momentum is going to be negative 0.003375 kilograms times meters per second. Then, when I go to find my final conditions, I will start with my net momentum, which is exactly the same as the beginning. And in this case, I was told that my momentum leaving was velocity final equals negative 0.315 meters per second. Question is, how fast does this leave? So my mass remains 0.015, and my velocity is still negative 0.315, to which I'm going to add a new mass, which is, the same mass, times a new velocity, which I don't know. And so I get negative 0.0033375 equals negative 0.00475 plus 0.030 velocity final. When I add 0.00475 to both sides, I get a grand total of 0.00135 equals 0.030 velocity final. I'm going to divide by 0.030, cancel, 0.030, and I get a velocity final of 0.045 meters per second, but because it is positive, it means that it is moving in that direction.